Hi, my name is Jean-Paul Rousseau, and with Melanie Bustamante and Lauren Kowalski, we're going to introduce the innovation of 3D bioprinting. The 3D printing of human organs, also called 3D bioprinting, represents the combination of a multitude of sciences, including engineering, biomaterial science, cell biology, physics, and medicine, just to name a few. 3D organ printing is defined as the 3D printing of an artificial device that is designed and constructed with the intent of replacing a human organ. 3D printing of synthetic organs currently constructs these artificial organs using a layer-by-layer method, adding each new layer on top of the previous layer. The 3D printing of organs is much more complex than ordinary 3D printing, as many new additional factors must be considered, including proper choice of materials along with the challenges associated with the acceptance of the new organ into a human body. While 3D organ printing is a very complex innovation and field, its uses are widespread and grow each day, showing great promise and potential for the future of healthcare. Now let's discuss a brief overview of the history of 3D printing and 3D printing of organs. The first 3D printer was developed in 1984 by Chuck Hull. This process is known as stereolithography, which simply means the making of solid objects by printing thin layers sequentially on top of each other. Since its creation in the 1980s, 3D printing has taken many forms, one of which is the use of stereolithography to print synthetic organs. The first bioprinter was created in 2003 by Thomas Bolin, as seen in the picture. Since the creation of the first bioprinter, the printing of various organs and cell lines has been a subject of heavy research for the medical community. In 2009, blood vessels were 3D bioprinted, marking the first case of successful 3D organ printing. Since 2010, new advancements and developments in 3D bioprinting technology has led to the successful creation of 3D printed bones, windpipes, and even some simple organs.
Hello, my name is Melanie Bustamante, and I am here to discuss with you the current use and status in regards to the 3D printing of organs. As of right now, we still have a lot of learning and research to do when it comes to the 3D printing technology for organs that can potentially function as replacement organs. Currently, we have had an advancement in bioengineering with the 3D printing of organs on chips. This chip, as seen in the image, is one that mimics the response of an actual organ in order to do drug testing. Our bodies are all different and can react to things differently, and this type of technology can reduce the cost when it comes to drug testing by eliminating animal testing, and it can also make sure that the drugs are more efficient. Organ on a chip has actual human cells, as seen by the different colors, that can be manipulated to learn the different types of reactions to drugs, toxins, and much more. There are 3 types of printing, with laser assisting printing being the one with the highest resolution, which is necessary for this type of technology. Most recently, there was a bioengineering team from Rice University that bioprinted the small air sacs from lungs. When it comes to any type of 3D printing of human tissues or organs, vascularization has been the biggest challenge because vessels can be extremely small. Vessels help with the transport of nutrients and oxygen to the organ and transport waste out. Because of this challenge, the bioengineering team created a technology called stereolithography apparatus for tissue engineering, or SLATE, that uses soft hydrogel material to make a structure one layer at a time. This technology uses blue light to solidify each layer after the liquid solution is placed. As seen from the image, the air sac they made is extremely small, and this can lead to hopefully printing of actual replacement organs. Overall, the making of organ on a chip and the bioprinting of tissues is a huge step in the right direction toward actual functional organ printing.
3D organ printing has the potential to be the next big thing in healthcare, and for a good reason too. Every 10 minutes, someone is added to the national transplant waiting list in the US alone, where on average 20 people die each day waiting for a transplant. Another shocking statistic reveals why the wait is so long to receive an organ transplant. Only 1 to 2% of the population dies in a way that makes them potential organ donors. Bioprinting organs may be able to compensate for the shortage of organ donors and make transplant waiting lists a thing of the past. There is the potential to create fully functional, complex internal organs like hearts, kidneys, and livers using bioprinting, although this is at least 10 years away. It's a long, difficult process to create a heart that actually beats, or a liver composed of thousands of tiny capillaries that must be arranged with the highest precision. It requires input from several fields like engineering, physics, and medicine. There has already been progress shown in 3D printing skin. The Wake Forest School of Medicine designed a printer that can print skin cells directly onto a burn wound. This is great news for burn patients since the traditional treatment for burns involves harvesting healthy skin from an unburnt part of a patient's body, which can be traumatic for the patient to heal from. 3D organ printing isn't just a breakthrough for patients, but also for physicians. Surgeons will be able to plan their surgeries more effectively and improve medical outcomes as a result. They will also be able to rehearse procedures using 3D printed models, which means the actual procedure can be completed faster and with less trauma for patients. A limitation of 3D organ printing is that technology as advanced as this involves machines that will probably cost hundreds of millions of dollars to produce. There are also ethical dilemmas that come with the technology. The incredibly high cost of bioprinters and materials may make people question whether bioprinting will only benefit the rich, and if the general populace will be able to afford 3D printed organs. There is no immediate or feasible way to subsidize their prices since the medical products needed to create the organs cost so much to engineer and utilize.
Our discussion questions are: first, do you believe that socioeconomic status will play a role in determining who receives 3D bioprinted organs first? And second, what ethical issues do you think could arise due to 3D bioprinting? These are our sources.